Hey everybody, I wanted to do one more sample problem from the worksheet about how to predict products and then balance and then write a net ionic and total ionic equation. So there are, like I said, a couple of different ways to just predict products. Where you can switch the name or you can write the formula. I am always going to choose to write the formula out because I think that helps us later on in the long run with whatever we need to do. So for silver nitrate, that's Ag, and that's a plus, and then nitrate is NO3 minus. So the formula that is created by that, there's the least common multiple is 1, so there's one of these and one of these. So silver nitrate is AgNO3. Okay. Plus potassium phosphate, okay, with a 1 plus. Then phosphate is PO4 minus. The least common multiple is 3, so that means we need, between the charges, so that means we need 3 of those and 1 of those. So this is going to be K3PO4. Now, we don't know what the products are, nor do we know what the formula of the products are. So I'm going to, off to the bottom, or down at the bottom here, I'm going to make my little Punnett square thing. It's not even close to a Punnett square, but I like it. And so what I'm going to do is I'm going to take this compound here, the first one listed. It doesn't matter, again, which one's first, which one goes up here and which one goes down here. But I'm going to put Ag plus here, and then I'm going to put nitrate here. Now, if it's a polyatomic ion, just keep it together. An ion acts as a whole unit. Okay, so if it's a polyatomic ion like nitrate or a monatomic ion, one atom, like silver, it's all still just one unit. So nitrate is just going to act like it normally does. Okay, and now potassium is going to be K plus, and then phosphate, PO4 minus. Now, again, we know that we have positives and positives aren't going to be attracted to each other, and negatives aren't going to be attracted to each other. So what are the products going to be? Well, we have KNO3 because this is a plus and this is a minus. So this 1-to-1 ratio is pretty common. So that's going to be KNO3. Potassium nitrate. Notice potassium nitrate. Flip the two, and now Ag with a plus and then a phosphate, PO4 minus. There's 3, and so that's 3. So this is going to be Ag3PO4. Okay, so the products of this reaction that we determined by using the little thing down here is going to be KNO3 plus Ag3PO4. Now, those are the products of the reaction, but we want to keep going with this. Okay, now what we can do is we can balance it now, or if we wanted to, we could write the states and the net ionic equation. So I think that we should do the net ionic equation first, so we need to know the states. So we go back and we look at our solubility rules. Now, fortunately, all of this falls under the right solubility rules that we have. Okay, so we know that nitrates, every single nitrate in the world is soluble. So this is going to be aqueous. Okay, and this is our molecular equation. Perfect. And then all potassiums are anything with potassium, regardless of the phosphate. Okay, any compound with potassium is also always aqueous. Okay, so now here's one that's doubly aqueous. Doesn't mean that it's actually twice as soluble. It just means that, hey, here's potassium and a nitrate. Those are always aqueous. And now here's silver. We know that silver is the exception to most of it, most of the rules for solubility. Plus, phosphates in general are not soluble. So, and that's from solubility rules. And you can look those up, or you can have them, and that's it. Okay, so now once we do that, now we can come down here and we can write our total ionic equation. And so with our total ionic equation, we take anything that is an ion, or anything that's soluble, that's aqueous, and we split it into its ions. And we have the list of ions right here. So that makes things work out pretty well. So this is going to be Ag plus aqueous plus nitrate aqueous. And we can balance this later. So it doesn't matter about the subscript to make sure you get the right formula. Okay, later on we'll balance it. It does matter that we have the right formula of the polyatomic ion. Nitrate's polyatomic ion is NO3 minus. So we need to keep that 3 there. Okay, so now it's going to be plus potassium ion aqueous plus phosphate ion 3 minus aqueous. My aqueuses start looking really bad. Okay, now that's going to react to form potassium aqueous plus nitrate aqueous plus silver Ag3PO4. And we have to keep that because this is the solid. That's the formula of the solid, so we keep that there. And actually, here's a little hint, and this is how I'm going to know that you've watched this video all the way through, is that you can underline solids, and actually that is what we do, because in solids, in reactions of solids, guess where we find the solids in the reaction mixture? If we react in a beaker, okay, we find them floating around in the solids, so it's almost like it's underlining the reaction mixture. Okay, so now we can write the net ionic equation, the overall change. So we're going to cancel out the things that are the same on both sides. So this is K, K, NO, NO. And so what we're going to get is Ag plus aqueous plus PO4 3 minus aqueous reacts to form Ag3PO4 solid, and that becomes underlined because that's a precipitate. And now we can balance this guy. Again, I can't emphasize enough about how awesome it is to have this out already done for you. That work is invaluable as we keep going. Okay, so how many silvers do we have? Let's balance in blue. Okay, how many silvers do we have? We have 3 here, but only 1 here. So I'm going to put a coefficient of a 3 there. Okay, now the next thing that happens is that we have phosphate, and now this is where people get confused. We only have 1 phosphate here. Okay, even though there's a 4 down there, there's only 1 phosphate. Remember, phosphate, the polyatomic ion, is POOO. Okay, 3 minus. I didn't put all my electrons in there, but it's all 1 unit with 4 oxygens. So we have 1 phosphate, and in here we also have 1 phosphate, even though it's not indicated. Remember, 1s we don't write if we don't have to. So here we have the balanced net ionic equation where the coefficients are 3 and then 1 and then 1. Okay, so that's how we do question number 2. I hope that helps, and we'll talk to you later.